The ocean has places so strange they feel almost alien. Massive trenches deeper than mountains are tall. Underwater cave systems untouched for thousands of years. Entire ecosystems thriving in permanent darkness. But few places on Earth inspire the same mixture of awe, unease, and obsession as a perfect dark circle sitting in the middle of the Caribbean Sea. A place enormous enough to be photographed from orbit. A place that sailors once steered around out of superstition. A place that swallowed two divers and held their remains for years without giving them back. This is the Great Blue Hole. And what scientists found at the bottom, including what the sediment layers told them about the collapse of an entire civilization, may be even stranger than any legend the locals ever invented. Tonight, we descend into one of the most scientifically important and genuinely eerie underwater locations on Earth. What the blue hole really is, what it has preserved in its depths, and why the truth turns out to be more unsettling than the myths. Off the coast of Belize, roughly 70 kilometers east of Belize City near a remote formation called Lighthouse Reef Atoll, a massive dark circle opens into the sea like a trapdoor in the floor of the Caribbean. The numbers are hard to fully absorb, approximately 300 meters across, nearly 1,000 feet, and 125 meters deep, about 410 feet. It is one of the largest marine sinkholes on the planet, and from above, the contrast is immediate. Surrounding waters are the vivid turquoise of a shallow tropical reef. The blue hole itself is a shade of blue so deep it reads as almost black, a circular void of a different nature entirely dropped into the middle of ordinary sea. Satellite images and aerial photographs made the blue hole famous long before most people ever learned anything about what it contains. That overhead view, the dark circle ringed by the pale reef, so geometrically perfect it looks deliberate, is one of the most reproduced ocean images in the world. But the view from above tells you almost nothing about what is happening below the surface. For that, we need to go back to the man who first brought the world's attention to this place. In 1971, Jacques Cousteau sailed his research ship Calypso to Lighthouse Reef Atoll and descended into the blue hole with his dive team. Cousteau was already the most famous ocean explorer alive, the man who had helped develop the aqualung, produced Oscar-winning documentaries, and made the deep sea legible to a global audience that had previously thought of it as pure darkness and danger. When he described the Great Blue Hole as one of the top 5 diving destinations on Earth, the world paid attention. What Cousteau's team found inside the sinkhole helped establish the basic understanding we still work from today. The walls of the blue hole are lined with enormous stalactites, stone formations that can only grow in air-filled caves. Their presence deep within a submerged sinkhole was immediate geological evidence of something significant. This cave had not always been underwater. And there was a detail in those stalactites that Cousteau's team noted carefully. They are not hanging straight down, they are tilted, off vertical by roughly 12 degrees. That tilt is a geological fingerprint. When a stalactite forms, it grows straight down along the pull of gravity. If the stalactite has since shifted angle, then the cave itself shifted after the formation was already in place, through tectonic movement, subsidence, or some kind of geological settling event. The stalactites inside the blue hole are not just proof the cave was once above water. They are proof the entire formation moved at some point after that, a detail that still has not been fully explained. Cousteau's visit made the blue hole world famous. It also established a pattern that would repeat decades later. Each time humans descended with better technology, the blue hole gave up a little more of what it had been holding. To understand what the blue hole actually is, you have to go back roughly 14,000 to 18,000 years, to the height of the last ice age. Sea levels worldwide were dramatically lower then by approximately 120 meters compared to today, because enormous volumes of Earth's water were locked in ice sheets covering much of the northern hemisphere. The land that is now the seafloor around Lighthouse Reef was above water. What is now the Great Blue Hole was a dry limestone landscape. Rainwater, slightly acidic from absorbing carbon dioxide in the atmosphere, slowly dissolved that limestone over thousands of years, carving out an underground cave system. The same process that creates cave networks across the world today. Chambers formed. Ceilings grew elaborate with stalactites. Floors built up with stalagmites rising to meet them. An entire subterranean architecture assembled itself in darkness over millennia with no human witness. Then the Ice Age ended. As global temperatures rose and the ice sheets melted, sea levels climbed. Coastlines were drowned. The limestone landscape around the cave flooded. Eventually, water filled the cave itself. And at some point, the exact timing is still being refined by researchers, the roof of the cave system became too heavy or too saturated or too undermined and collapsed. The cavern became open to the sea above it. What remained was a near-perfect circular sinkhole, the ancient cave's footprint, now exposed and now filled with ocean water, now sitting on the seafloor where dry land had been. That is the Great Blue Hole, not a crack in the earth, not a bottomless pit, not a gateway to anything supernatural, a drowned cave, its ceiling gone, and its walls still lined with the stalactites that formed when it breathed air. The formation is part of the Belize Barrier Reef Reserve System, which UNESCO designated a World Heritage Site in 1996, recognition of the entire reef ecosystem's extraordinary biodiversity. The blue hole sits at the center of that system like a strange jewel, geologically ancient and ecologically unlike everything surrounding it. Here is where the story becomes genuinely unsettling, independent of any legend. Near the surface, the blue hole's walls support marine life much like the surrounding reef. Light reaches down far enough to sustain some coral and algae. Fish move through the upper sections. Nurse sharks in particular are well-documented visitors and have made the site famous among recreational divers. But recreational divers with standard equipment and standard certification rarely descend more than 40 meters. They experience the beautiful, photogenic shallow portion of the blue hole. Clear water, impressive walls, and if lucky, the occasional shark gliding past. Everything that makes the blue hole scientifically remarkable happens far below where most divers ever go. As depth increases, sunlight fades. More importantly, the blue hole's enclosed shape and depth create a condition called stratification. The water layers stop mixing. Oxygen-rich surface water does not circulate down to the lower depths. Without oxygen exchange, the deep water becomes progressively depleted. Below approximately 90 to 100 meters, the dissolved oxygen concentration drops to near zero. This is the hypoxic zone, water chemically hostile to most animal life. Fish do not go there. Coral cannot grow there. The transition is not gradual in the way one might imagine. There is a visible boundary layer, a kind of underwater thermocline where the chemistry of the water shifts noticeably. Below that boundary, conditions become actively toxic. Hydrogen sulfide, a gas produced by the anaerobic breakdown of organic material in the oxygen-starved sediment below, accumulates in a distinct layer. In high concentrations, hydrogen sulfide is lethal to most complex organisms. It is the chemical responsible for the smell of rotten eggs, and in the blue hole, it does not merely exist in trace amounts. It forms a dense, cloudy horizon visible in underwater photography as a hazy, almost foggy band cutting across the abyss. Below the hydrogen sulfide layer, nothing. No fish, no coral, no marine mammals, almost no visible life of any kind. Just the sediment, undisturbed, accumulating slowly, holding what it has collected for thousands of years. This is the part of the blue hole story that gets the least attention in popular coverage and deserves the most. Because the anoxic environment at the bottom, so hostile to animal life, is extraordinarily good at preserving information. The organisms that normally decompose organic material require oxygen. In the oxygen-free depths of the blue hole, hole, that decomposition slows to nearly nothing. Material that sinks into the dead zone is preserved in the sediment layer with unusual fidelity. Shells, pollen, organic carbon, as well as minerals deposited by specific weather events. Layer upon layer accumulating in sequence, each layer representing a slice of time. Sediment cores extracted from the blue hole floor are, in effect, an environmental archive. Scientists can read them the way historians read documents, and what those sediment cores have revealed is extraordinary. Researchers analyzing blue hole sediments have reconstructed Caribbean hurricane activity, stretching back approximately 3,000 years, identifying patterns in storm intensity and frequency that no written record could provide. The physical traces left by major storms, specific sediment disturbances, particular mineral deposits, are legible in the layers. But the finding that has attracted the most attention from historians and archaeologists is this. The sediment record shows evidence of a prolonged severe drought across the Yucatan Peninsula and surrounding region roughly between 800 and 900 CE. That date corresponds almost exactly to the collapse of the classic Maya civilization. The classic Maya collapse is one of the great unsolved mysteries of ancient history. One of the most sophisticated civilizations in the pre-Columbian Americas, with advanced mathematics, astronomy, architecture, and writing systems, began abandoning its major population centers within the span of roughly a century. Populations that had numbered in the millions contracted catastrophically. Cities were left empty. The causes have been debated for over a century. The blue hole's sediment record does not solve that debate, but it contributes a significant piece of evidence that the period of Maya collapse coincided with environmental conditions, specifically drought severe enough to leave a clear signature in the geological record of a sinkhole more than 300 kilometers from the Maya heartland. The bottom of the Great Blue Hole may contain partial answers to questions about human civilization that scholars have been asking for over 100 years. That is not a myth. That is active, peer-reviewed science. Despite decades of diving and study, much of the blue hole remained poorly mapped as recently as 10 years ago. The depth, the toxic lower layers, and the logistical challenges of working in such an environment meant that systematic exploration had been limited. In 2018, a major expedition changed that. The team was organized around 2 submersibles capable of operating at depth with scientific instrumentation. Among those aboard were Sir Richard Branson, marine scientist and submarine pilot Erica Bergman, and Fabien Cousteau, oceanographer, filmmaker, and grandson of the Jacques Cousteau, who had first brought international attention to the blue hole nearly 5 decades earlier. The continuity was deliberate. The Cousteau family connection to this site stretches across 2 generations and nearly 50 years of exploration. Using advanced sonar imaging, the team produced the most detailed map of the blue hole's interior ever created. The results confirmed and expanded what earlier dives had found: enormous stalactite formations along the walls, the visible chemical layering of the water column, the eerie stillness of the lower sections. And then the team reached the bottom. The sediment there was largely undisturbed, fine, pale, soft, almost no current, almost no biological activity. In the submersible's lights, it looked less like a seafloor and more like the floor of an abandoned room. Among the sediment and the darkness, they found 2 things that nobody had announced publicly before the expedition. The first, plastic. Bags and bottles, identifiable debris from human activity, sitting at the bottom of a sinkhole more than 400 feet below the surface of the Caribbean Sea, at the bottom of one of the most remote marine formations on Earth. If you were looking for a location that embodied far from human impact, the bottom of the Great Blue Hole would have seemed like a strong candidate. It was not. Plastic had already arrived. The second, bones. The skeletal remains of 2 divers were found at the bottom of the blue hole. divers who had gone missing in the sinkhole and had never been recovered. The team notified Belizean authorities and, out of respect, left the remains in place. Both discoveries, the plastic and the bones, say something true and difficult about the world, that there is no place left on Earth fully outside the reach of human activity, and that the blue hole, for all its geological indifference, does not give back what it takes. The 2018 expedition was the most comprehensive study of the blue hole conducted to date. It was not the last word. The sediment archive at the bottom has been only partially sampled. Researchers are still analyzing cores. The full climate and hurricane record encoded in those layers has not been completely read. The connection between the blue hole's environmental data and the Maya collapse is suggestive but requires more corroborating evidence from other sites. The tilted stalactites remain incompletely explained. The tilt documents that the cave shifted after its formation, but the precise mechanism and timing of that shift have not been definitively established. And the broader question, how many other submerged cave systems, drowned landscapes, and flooded coastal settlements exist on the world's continental shelves holding their own archives, remains almost entirely unanswered. Humans have mapped roughly 20 to 25% of the ocean floor at high resolution. The rest is, by any honest measure, still largely unknown. The Great Blue Hole is visible from space. Its overhead image is one of the most reproduced photographs of the ocean in history, and it is still, in important ways, not fully understood. That gap between familiarity and knowledge is worth sitting with. The Great Blue Hole is not supernatural. It is not bottomless. It is not home to monsters or lost civilizations or secrets that the scientific establishment is hiding. What it is, examined clearly, is this: a drowned Ice Age cave. Its formation shifted by geological forces we have not fully traced. Its depths chemically hostile to most life. Its sediment layers holding a continuous environmental record stretching back thousands of years. A record that has already produced evidence relevant to one of the great unsolved collapses in human history. The plastic at the bottom tells us something about the present. The bones tell us something about the cost of the deep. The sediment tells us something about a civilization that fell more than 1,000 years ago. Jacques Cousteau descended here in 1971 with the technology of his era and declared it worth the world's attention. 50 years later, his grandson descended in a submarine and found that the world had already left its mark on the bottom. The ocean keeps secrets better than almost anything on Earth, but even the ocean, it turns out, cannot keep ours. If this is the kind of content you want more of, real science that turns out to be stranger than the myths, subscribe to the MindSpark archive. Drop a comment. Knowing what is actually waiting below the surface, would you descend into the Great Blue Hole? And what other underwater mysteries do you want us to cover next? We look forward to hearing from you. Thanks for watching.